All right, so I'm going to be going over 2.6, solve quadratics using the quadratic formula. This method is really nice because all we need to solve it is the values of a, b, and c, and we plug them into the quadratic formula that looks like this right here, and that gives us the solutions. And so really importantly, before you can use the quadratic formula, you want to make sure that you have something of the form ax squared plus bx plus c is equal to 0. So in this case, if we look at these numbers, which are given to us, that means that we would have the formula x squared, right? A would be equal to 1, a 1 not written there, plus 4x minus 5 is equal to 0. And so if we had something that looked like this, we'd be able to identify a, b, and c, and we can solve it simply by plugging those values into our quadratic formula. So using these values of a, b, and c, x is going to become -4 plus or minus the square root of 4 squared minus 4 times 1 times -5 all over 2 times 1. And so just to keep track of everything, we took our a, which is 1, and that shows up there and there. We took our b, which is 4, and that shows up there and there. And our c, which is -5, shows up right there. All right. So now I'm going to start to evaluate some of this. And so we're going to get x is equal to -4 plus or minus the square root of 16. And now we have to be very careful with our signs here. So we have -4 times 1 times -5. That's going to become +20 all over 2, which is going to become -4 plus or minus the square root of 36 all over 2. Remember, now we are just simplifying our answer. And so the square root of 36 is a perfect square. So that would be equal to -4 plus or minus 6 over 2, which means that we would have a -4 plus 6 over 2, which would be equal to 2 over 2, which is equal to 1. Right, -4 plus 6, 2 on the top, 2 on the bottom. And you would have -4 minus 6 over 2, which would be -10 over 2, which would be -5. Meaning that in this case, x would be equal to -5 or 1. Moving down to these examples, again, we want to first make sure the equation is make sure the equation is equal to 0 and written in standard form. So in order for it to be in standard form, we need everything on the left side, this to be equal to 0. So the first thing we're going to want to do here, subtract 7 from both sides. That's going to give us -3x squared plus 8x minus 7 is equal to 0. Remember, we can't subtract 8x minus 7 because those are unlike terms. We just need to leave it 8x minus 7. So now we can identify our variables. A is equal to 3, b is equal to 8. And remember, we want to keep the sign with it. So a would actually be -3, b would be 8, c would be -7. And if we want to see where those come from, a, b, and c. All right, and then we're just going to go ahead and plug it into our quadratic formula. You might notice here that you might see this written a couple of different ways, but they're the exact same. Here we have a negative b. Here we have a negative 1b. Doesn't matter. Either way works. The 1 might just help you keep track of the negative sign out in front. And here we have plus negative 4ac versus minus 4ac. So whether you write it this way or whether you write it that way, doesn't matter. You'll get the same answer because positive and negative, like plussing a negative is the same as subtracting, and 1 times b is equal to b. So that out of the way, let's go ahead and start plugging things in. So x would then be equal to negative 8 plus or minus the square root of 8 squared minus 4 times negative 3 times negative 7 all over 2 times negative 3. And this is going to become negative 8 plus or minus the square root of 64. And here we have to be really careful about our signs because we have negative 3 times negative 7 times negative 4. So a negative times a negative is a positive, times another negative becomes negative again. It's going to be minus 84 all over negative 6. And so that becomes x would then be equal to negative 8 plus or minus the square root of 60 minus 64. That's negative 20 over 6. So if we're trying to simplify our answer here, we want to simplify the radical. So the square root of negative 20 is not fully simplified. I'm going to write that out over here. If we wanted to fully simplify it, we would first want to do square root of negative 1 times the square root of 20. Square root of negative 1, that becomes I. Here we can go 5 and 4, and 2 and 2. Square root of 2 times 5 means that this is equal to 2 root 5, 2I root 5. So this would become negative 8 plus or minus 2I root 5 over negative 6. And here, we want to simplify this as far as possible. So we want to look for the greatest common factor between all of the numbers here. You can see negative 8, 2, and 6. Those can all be divided by 2. And we generally want to make the denominator positive. So we would actually want to divide by negative 2. And so when you divide by negative 2, you're going to get x is equal to the set that contains 4, right? That's 8 divided by negative 2, plus or minus 2I root 5. And here we leave the plus or minus, even though we're dividing by, oh, wait, that should actually just be plus or minus I root 5, because when we divide by negative 2, we want to divide everything by negative 2. So 2 divided by negative 2 would be negative 2, but we just leave the plus or minus because even though we're dividing by a negative, if it's plus, it's going to become negative. If it's negative, it's going to become plus. And either way, we're still going to have both positive and negative. And so then all of that over 3. And that's your final answer. All right. So now we're going to want to get this one in standard form. What we're going to want to do is add 2x to either side. Remember, we can't combine like terms here. We can't combine x squared with 2x or 63 with 2x. So we're just going to write it x squared plus 2x minus 63 is equal to 0. And then we want to label our variables. So a would be equal to 1, b would be equal to 2, c would be equal to um, c would be equal to negative 63. So when we go to plug that in, we're going to get x is equal to negative 2 plus or minus the square root of 2 squared minus 4 times 1 times c, which is negative 63. Remember, 1 is a, all over 2 times 1. So when we start to simplify that, we're going to get negative 2 plus or minus the square root of 4 plus 252 all over 2. That means that x is equal to negative 2 plus or minus. If you're wondering where this 252 came from, that's negative 4 times 1 times negative 663, or negative 63. Ooh. That's going to be times the square root of 256 all over 2. And so at this point, if you're good with your perfect squares, you'll recognize that the square root of 256 is 16. Your negative 2 plus or minus 16 over 2. If you don't see that the square root of 256 is 16, you can always do prime factorization, just like we did up here. And that will get you the same answer. And so now we can think about that as, right now we can simplify that further. We can think about negative 2 plus 16 over 2. That's going to be 14 over 2 is equal to 7. We can do negative 2 minus 16 over 2, which is going to be negative 18 over 7, or over 2, which is going to be negative 9. And so x is equal to negative 9 or 7. All right. So now we're looking over here. We want to subtract 93 from each side because we want to get it to be equal to 0, right? That's the goal here, to get it equal to 0. So that's going to leave us with negative x squared. And this time, I'm going to write plus 0x, right? Even though we don't have even though we don't have any x terms here, we still want to write it in standard form, so we can include a 0x. If you leave out the 0x here, it's not going to change your answer. You just need to make sure that you're keeping track of the value of b being equal to 0. So minus 93. If we do 18 minus 93, that gives us minus 75. And this would be equal to 0. So when we're labeling our coefficients, we're going to have a equal to negative 1. There's a negative sign out in front. B is going to be equal to 0 because we don't have an x term anywhere in here. Then c is going to be equal to negative 75. So now we're going to plug that into our formula. Negative 0 plus or minus the square root of 0 squared minus 4 times negative 1 times negative 75 all over 2 times negative 1. Negative 0 is, of course, just 0. So you'd have plus or minus the square root of 0. And again, keeping track of our signs here, we have a negative times a negative times a negative. That's going to be a negative. And it's going to be negative 300 all over negative 2. So we're going to have plus or minus the square root of negative 300 over negative 2. And so we want to simplify this all the way, including the radical negative 300. We're going to start by pulling out the negative 1, and then we're going to have root 300. It's going to become I. I'm going to recognize that as root 100 times root 3, or 10 root 3. Let me say that we have plus or minus 10I root 3 over negative 2. And because we don't have anything else being added or subtracted on the top, we can actually just divide these two, 10 by -2, and you'd get -5, but because we have the plus or minus there, um, if it's positive and you divide by -2, it's going to become negative. If it's negative and you divide by -2, it's going to become positive. So we're still going to have the positive or the negative. So only in this case, because we don't have anything else being added on the top, like here, how we had -2 plus or minus, or up here, actually, how we had -8, so we had to keep track of the negative sign. Here we don't need to, and we can just write this plus or minus 5i root 3. The 5 came from dividing the 10 by the 2.